what is horsepower? So if we want to understand what horsepower is, then we have to go to its history. When James Watt, he was a Scottish inventor, invented his steam engine, he expected that his engine will displace the horses. Why? Because at that time, for lifting water or drawing a cart, horses were used. Now he thought that his engine will replace these horses, so he actually wanted to compare his engine's power with horses' power. Let us take an example to understand what actually horsepower is. Let us consider this is an well, and we have to draw water from it. A horse is actually lifting some water for a certain amount of time. Then we are going to displace this horse, and in its place we are going to put James Watt's engine. Okay, let us say that this is James Watt's engine. So when this wheel is rotating like this, this rope will move in this direction and water will be lifted. So this is James Watt's engine. Now this engine has also worked for 2 hours. If the water lifted by the horse in 2 hours and by this engine in 2 hours is same, then we can say that this engine has power of 1 horse. Its power is similar to 1 horse. Then we may very easily say that its power is 1 horsepower. It is very simple, but now we cannot do this experiment with every single engines, isn't it? So what we have to do is we have to quantify how much actually 1 horsepower is. So let us now quantify it. What James Watt did was, let us say that he has done this experiment. Maybe he has done some other experiment, but for our understanding, let us consider that by this experiment we have reached to the conclusion of how much a horsepower is. For the condition where we actually considered the horse, let us say in T minute, the horse has collected m pound of water. Pound is a unit of mass, and the distance of this rope is maybe L feet. Okay, power is equal to how much? So first of all, what is the definition of power? Power is work done per unit time. Work done by time. So the work done by the horse is equal to mass, and of course it has to be multiplied with the gravitational acceleration, that is g. So we write it like pound force, not feet, pound force into a distance, that is L, this distance, and this is in feet. So this is work done, this much work is done at time, how much? T time. So per unit time by T minute. So this is actually the power of the horse. So if you put this value M, L and T, what you will get is 33,000 pound force foot per minute. Okay, if you want power per second, so you have to divide it by 60, so it will be like 0 pound force foot per second. 1 horsepower is equal to this much. This is power of a horse. Now how do we compare this power with power of an engine? So we know 1 horsepower equal to, by experiment, 33,000 pound force foot per minute. Okay, now let us see an engine. This is the cylinder of our engine, this is piston, and okay, its arrangement is like this. Piston moves upward and downward. Maybe we consider that is its length of stroke is L, means its maximum height is this much and minimum height is this much, so its distance is L foot. Okay, area of this piston is, let us say, a inch square. So please notice I am taking this distance in feet, but its area in inches. And average pressure on the piston is let us say pm, pound force per inch square. Okay, pound force is actually force, it is force, isn't it? Pound into gravitational acceleration. So this is a force, and when we actually calculate pressure, we divide it by area. So pm is pressure, pound force per inch square. So now let's see how much work is done. But if in a power stroke this stone moves from this position, minimum position, to the maximum position, how much work is done? So we have to find force, and then we have to multiply it by distance, isn't it? So for what is force? Here pressure is given, pm, pound force per inch square. We have to multiply it by area, isn't it? Area, which is in inch square. So it becomes force, pressure into area, it becomes force, into distance. So force into distance, it becomes work done. So if this much work is done per stroke, per power stroke, and if we say that per unit time n power strokes are there in our engine, then per minute the work done will be into n, isn't it? So how much? pm L A into n. Inch square is gone. So pound force foot per minute, because n will be in per minute, isn't it? N per minute. This will be the power of engine. Now we know that 1 horsepower is this much pound force foot per minute. So for example, let us say that for this engine, if we put these values pm, L, A and n, let us say 66,000 pound force foot per minute is coming. Okay, then how much is horsepower of this engine? Horsepower will be, of course, 66,000 by 33,000, and of course their units are same, pound force feet per minute. Pound force feet per minute will be out, so we will get a real number 2. So this engine has horsepower 2. So this engine is 2 HP engine. This is horsepower, and this is how we calculate horsepower. So in this video we are going to actually convert HP, HP, into, HP, into, HP, 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 1 horsepower equal to 33,000 pounds force fit per minute. So this is equal to 33,000. 1 pound equal to 0.0.4539 2 kg into F. This is gravitational acceleration. In SI unit, gravitational acceleration is 9.8 meter per second square into 1 feet is equal to 1 feet equal to 0.3048 meter, and here it is in minutes, so by 60 second. If you put all these values in calculator, you will get 745.7 watts. So this is how you can convert HP into watts. Okay guys, so I hope that in this video the concept of HP is completely clear to all of you. Thank you friends for watching this video. If you have any query, any doubt, please ask me in the comment section. Have a nice day.